If you've been keeping up with headlines about space recently, you may have noticed something strange. Scientists seem to be obsessed with one of Saturn's moons named Enceladus. But let's start by talking about something more tangible: water. Enceladus is a small moon, only about 500 kilometers across. That makes it smaller than Earth's moon. If it does, it would be very unlikely to find any large animals like dinosaurs or whales. Any life forms there would probably be microscopic like bacteria. So how exactly do scientists even go about hunting for creatures we can't see? It orbits Saturn alongside dozens of other moons and is thought to have formed at the same time as the planet billions of years ago. Instead, researchers are creating what's known as a miniaturized SEM. It'll still use electrons to image microbes. But instead of using a vacuum chamber to contain them like a traditional SEM, the miniaturized version will use electric and magnetic fields. That's because exploring, and even less so, colonizing the solar system is extremely dangerous. To put that in perspective, the amount of radiation outside Earth's orbit is about 40 times higher than what is considered a lethal dose. The plan is to mine the regolith in place and use it to construct buildings for human explorers. We have a Patreon where the people who want to support the work we do that so that we can keep doing it. You can find it at our support page. Of course, this assumes that humans will eventually set up shop on Mars too. It's all part of the grand plan to make humanity a multi-planetary species. But it seems clear that whatever happens first, Enceladus will be a major focus for space exploration over the next few decades. We'll be sending powerful new probes to the moon to search for life and test its habitability. And if we find what we're looking for, maybe someday we'll set up camp there too. And that's not taking into account the cosmic rays that are constantly bombarding the solar system. These particles can come from supernova explosions or the charged particles released by the sun during solar flares. They pose a special problem for astronauts because, unlike the radiation we experience on Earth, cosmic rays don't follow the inverse square law. That means that the further you are from a radiation source, the farther away its effects diminish. For cosmic rays, this effect is negligible, even at very large distances. So you'd be equally likely to die from a cosmic ray strike on a space station orbiting Earth, as you would on a mining outpost on Enceladus. Our spacecraft can be vulnerable to collisions with debris or attacks by extraterrestrial bodies like asteroids. That means any equipment we send to Saturn's system has to be designed to last for decades. It also means that humans traveling to and from Enceladus would need protection from micrometeorites. And we haven't even considered the effects of long-duration space travel on the human body. Spending even a year in space can cause muscle loss, bone loss, and vision problems. And that's not even the most significant danger. This will allow the instrument to operate in the near weightlessness of deep space. It'll also be able to analyze samples without the need for a conductive coating. But perhaps the greatest challenge is that it'll have to fit inside a probe just 2 centimeters in diameter. That's the size of a coffee cup. This device uses electrons instead of light to create images of tiny specimens. But once the technology is perfected, it'll be sent to Enceladus aboard the Dragonfly spacecraft. This mission is scheduled to launch in the mid-2020s and arrive at the Moon in 2034, along with searching for life. Dragonfly will study how the Moon's interior ocean interacts with its icy outer crust. It'll also measure the chemical properties of the plumes shooting out of the Moon's south pole. The mission should help scientists understand whether or not the Moon's ocean could support life, as we know it today, or whether it ever did in the past. For one thing, the Moon doesn't have a solid surface that we could just put the instrument on. There's a thick crust of ice on top, but below that is a slushy mix of water and rock. Second, any instruments we send to Enceladus will need to withstand incredibly harsh conditions. The Moon gets bombarded by cosmic rays and its gravity is weaker than Earth, as by a factor of 100. Third, Enceladus is very far away. Communicating with a probe on the Moon takes more than an hour for a signal to travel one way. And if anything goes wrong, there's no way to fix it. If you ever want to see a cool picture of a butterfly S-wing or a grain of sand or something else really small, Google images for scanning electron microscopy. The resulting photos will blow your mind. SEMs work by firing a focused beam of electrons onto a sample. Usually that sample is placed on a metal grid, and it needs to be coated in a thin layer of conductive material like gold or carbon. That's because the beam interacts with the sample by knocking electrons off its surface. If the sample isn't coated, those knocked off electrons would just dissipate and the image wouldn't form. But when the sample is coated, those freed electrons travel through the coating and build up on the underlying grid. Because the electrons can't escape there, this creates a current that S then uses to create an image based on where the electrons end up. An SEM can resolve details down to around 1 nanometer in size, which is incredibly precise when dealing with microbes. In fact, SIMs are sometimes used to help identify different types of bacteria. Different species tend to have characteristic shapes and structures that can be picked out with an SEM. Once scientists have identified the type of microbe, they can determine whether it's capable of sustaining human life. It's cold, dark, and far from the sun. But under its frozen surface lies an ocean of liquid water. We know that because back in 2008, the Cassini spacecraft performed a flyby through Enceladus's orbit. As it passed through the moon's path, it detected a plume of water vapor coming from the moon's south pole. These plumes were shooting hundreds of kilometers into space, carried there by the tremendous heat coming from the depths of Enceladus. Cassini also detected organic molecules in these plumes, meaning that the ingredients for life as we know it are present on the moon. You might not have heard of it until recently, but NASA has been studying this little moon since 2004, and they're not alone. There are plenty of asteroids and comets that zip by Earth occasionally, and they contain similar stuff. Those bodies are also often referred to as potentially hazardous. In contrast, scientists refer to Enceladus as a potentially habitable world. The difference is that while Earth is the only place we know for sure has life, conditions on Enceladus are likely hospitable for life as we know it. Or put another way, if you wanted to build a self-sustaining colony of humans far away from Earth, it would be a lot easier to set up shop on or in the vicinity of Enceladus rather than on an asteroid or comet. Space agencies around the world are eagerly awaiting the chance to get their own probes out there to investigate. What could be one of the most important places in the universe for humanity's future? Now you might be thinking that we're going to talk about aliens, and that's not wrong. But why does any of that matter? Water and organic molecules aren't all that uncommon in our region of space. We don't yet know whether or not life exists on Enceladus. The main tool in their arsenal is the Scanning Electron Microscope, or SEM. Of course, actually getting an SEM on Enceladus is a bit more complicated than I just made it sound. So how are we getting an SEM to Enceladus? Well, it won't be a physical instrument after all. NASA has already created a prototype miniaturized SEM. It doesn't have all the features they want yet, like the ability to move around on its own. But if we do discover evidence of ancient life on Enceladus, we'll still have some serious challenges to overcome before we can call it a hospitable place for human life. Scientists have discovered that deep space contains dangerous levels of radiation that can kill a person in a matter of hours. In order to protect people on long-duration space flights, engineers are designing habitats that are shielded from radiation by meters of Martian regolith, or the dust and small rocks covering the planet's surface. Thanks for watching this episode. If you want to help us explain even more mind-blowing space stuff to the whole internet,